And start recording. Hello, YouTube. Hello, world. Okay. All right. Welcome, everyone, to our next Water, Wetlands, and Watershed seminar. We are all virtual today, so it's good to see you on Zoom and out there on YouTube. Today, we are lucky enough to have with us Dr. Michael Wetz. So Dr. Wetz is the Endowed Chair for Coastal Ecosystem Processes at the Hart Research Institute for Gulf of Mexico Studies at Texas A&M University. That's in Corpus Christi. He's a broadly trained marine scientist with expertise in phytoplankton ecology and water quality. Grounded in aspects of coastal ecology, he's really focused on trying to solve environmental problems, not just figure them out. And so with the recognition that these kind of environmental and social problems are complex, he looks to balance environmental and human needs and use sound science for stakeholder-led restoration and management efforts. He's won a number of awards, including recently the Conservationist of the Year, that's awarded by the Coastal Conservation Association for his work in Baffin Bay, Texas, and also the Higher Education Award awarded by the Coastal Bend Bays Foundation. Twice, I guess. You won that one twice. That was pretty sweet. Mike led a volunteer water quality sampling program in Baffin Bay for 4 years. And I think you're going to show us some of those data, both sort of the more science, classic academic science-based work, as well as some of the stakeholder-based work. So with that, floor is yours, Mike, and thanks for coming to talk to us today.
Well, thanks, David, for having me. It's a real honor to be here. Hopefully I don't put too many people to sleep on Zoom here. So I appreciate the opportunity to talk about some of the water quality challenges that we have here in Texas. The state's just been growing like crazy in terms of population, and that obviously puts some pressures on a lot of our coastal ecosystems. So what I'm going to do today is just talk a little bit about some of those challenges that we're seeing and how we're trying to address those. So let me go ahead and pull up my screen here. All right. I think you can see me. So I'm at the end, not the beginning. I don't want to, we flew through that one. There we go. Okay, so let me give you a broad overview of what the Texas coast looks like, first of all, before I start to delve into some of the water quality issues. So we have about 367 miles of coastline from the Louisiana border down to the Mexico border. And on that coastline, we have 7 major estuarine complexes. So on the right here, this map shows the extent of the watersheds for our coastal water bodies. So some of our estuaries have watersheds that are relatively limited to just a short distance away from the coast, but then others, especially for our central Texas coast estuaries up through Galveston Bay, they have watersheds that run all the way up 500-600 miles to the west Texas border and beyond. So the defining feature of the Texas coast really is a very noticeable precipitation gradient that we have. So on the northeastern Texas coast up around Louisiana, we get a lot of rainfall on an annual basis. So our estuaries up to the north are very strongly river influenced. So Sabine Lake up here on the Louisiana border is Galveston Bay, down through the central coast, down through the central Texas coast. Those estuaries are all fairly strongly river influenced, and they have lower salinities, generally brackish. They also have expansive marshes and wetlands. And then once you get down around the Corpus Christi area, so on this map, it says Nueces, that's the Nueces estuary. Corpus Christi is basically adjacent to that. Once you get down here, we start getting into that part of the precipitation gradient where the rainfall becomes more sparse. And so from Corpus Christi south, we don't get a lot of rainfall on an annual basis. So our estuaries don't receive a lot of freshwater inflow. They're frequently hypersaline, and they tend to be seagrass dominated ecosystems. So another way of viewing what our estuaries look like in terms of that defining feature, the freshwater inflow and precipitation gradient, is this middle panel. It shows the freshwater inflow balance. So in other words, on an annual basis, does the estuary receive more fresh water than it loses, for instance, to evaporation, or does it receive less? So you can see again up here on the northeastern coast, the Sabine Neches estuary, what we call the Trinity San Jacinto estuary, also known as Galveston Bay. And through those central coast estuaries, we tend to have a positive inflow balance, meaning that we get more freshwater inflow than we lose. And then once you get down to Corpus Christi Bay and the Laguna Madre area, again, that's where you're seeing the higher evaporation rates and lower inflow. So again, that's why we tend to see hypersalinity fairly frequently in our lower coast estuaries. So with that being said, to the broad overview of what the Texas coast looks like, I wanted to talk a little bit about some of the changes and pressures that we've been seeing here in Texas. Like I mentioned earlier, we've had really incredible population growth in our coastal watersheds over about a 10-year period. In the last decade, we saw a 15% increase in the population. And so this is resulting in obvious changes in land use. So this map on the upper right just shows the rate of land conversion from more natural lands, rangelands, grasslands to urbanized areas. And you can see all of our major metroplexes, the Houston area, the San Antonio, Austin, Gateway, up around Dallas, and even down in the Rio Grande Valley. So we're seeing this urbanization that puts obvious pressure on our water bodies, primarily because it can lead to increased nutrient and bacterial loadings, especially when you don't have great wastewater treatment or good BMPs to deal with pollutant runoff. And it's also leading to really strong growth in the demand for fresh water, either for human consumption or for irrigation. Also, just wanted to point out this map in the lower right is just another example of the urbanization and the population growth that's happening. This just shows the change in the number of residential private septic tanks throughout the state. So over about that 25-year period from 1990 to 2016, we saw an increase of about 900,000 septic tanks being built in the state. And a lot of those are really concentrated in our coastal watersheds. So aside from the land use change and the population growth, one of the things that we've also been seeing is an increasing need for reliable water sources, so more reservoir and dam construction. And this has had an impact on our downstream ecosystems as well. So this is an example from the Nueces estuary. The Nueces River flows into the Nueces estuary. So the Nueces estuary also encompasses Corpus Christi Bay. So it's part of one big estuarine complex. And what this shows is the inflow balance for the Nueces estuary prior to a period of intensive dam construction from the 1940s to 1950s. During that time, the inflow balance was generally positive on average, and we saw a fairly large range, including evidence of pretty significant freshwater pulses from time to time that came into the estuary. Then we had this period of dam construction. And while the sort of average inflow balance stayed about the same, we started to see the constriction in terms of the flood pulses that used to be common in terms of coming down the river to the estuary. And then in that sort of after period, after the dams had been constructed and the reservoirs started to fill fully, we've now seen a reduction in the base flow coming down the river to the estuary, and also a reduction in terms of the flood pulses. So again, this estuary, this is very common for many of our central Texas coast estuaries, and it's had some very significant impacts on the hydrology and the salinity characteristics of our estuaries in the region. I'll talk more about that in a minute. So aside from those issues, we have climate pressures affecting Texas. It's definitely getting warmer, very well documented trends in terms of air temperature and water temperature for much of the Texas, for much of the state. We're seeing places in Texas where there's an increasing precipitation trend, especially in southeastern Texas, up around Houston and over in the Beaumont area, and also down in the Rio Grande Valley. But then out in West Texas, where some of our watersheds reach into, it's getting drier. And we're certainly starting to see some major water availability issues out in West Texas in particular. And then also we're starting to see some evidence of rainfall becoming more intense in some areas, especially over here in East Texas, around the Houston, Galveston area. But we are, even in our location here in Corpus Christi Bay, we're starting to see evidence of more intense rainfall when it does rain. So last year, for example, we had one of the craziest flooding events any of us have ever seen, including old timers down here. We had something like 12 inches of rain in a 24-hour period, which is extremely uncommon when it's not associated with a hurricane. So what I want to do today is highlight some of the impacts that the changes we're seeing have had on water quality on the Texas coast. This is really what my lab does. We focus on water quality issues. As David mentioned, I'm primarily trained as a phytoplankton ecologist, so I do a lot of work with harmful algal blooms and nutrient issues. But what we've also started to do, especially in response to concerns from stakeholders and needs expressed by state agencies, we've started to look more broadly at existing data sets that we have out there to look at more general characteristics of water quality, like the salinity, bacteria levels, as well as nutrients and algae. So the focus of the talk is going to be identifying where the problems are. I'll talk about some of the analyses that we've done to look at where we have these problems, where we have the data. I'll talk about what we think the drivers are, and then also a little bit about what the future holds. Feel free to speak up if you have any questions at any point. So in Texas, we are, I guess, blessed in the sense that we actually have some pretty decent long-term water quality monitoring data sets that we can mine and look to figure out where those hotspots are and where the real challenges are in terms of water quality issues. So our state EPA, the Texas Commission for Environmental Quality, maintains a water quality monitoring program for a variety of parameters, salinity, nutrients, metals, up and down the Texas coast. All these black dots indicate sampling stations. So TCEQ will go out on a quarterly basis and make their measurements in these different locations. So depending on the base system itself, this monitoring program has anywhere from about 20 years up to 40 years or so of data for a particular location. We also have what's known as the Beach Watch program. This is our state's bacterial monitoring program for our beaches. Beach Watch has been in existence for about 15 to 20 years now. So it's pretty good spatial coverage, so we can also really start to look at the hotspots from a bacterial standpoint. And so what we've done is essentially mine these data sets, again, to look at where the real issues are here in Texas. So I want to start off just talking about salinity. So what this graph shows are a couple of things. There are some background colors on here that indicate the average salinity conditions over a 10-year period. And then all of the little dots indicate whether there's a trend or not. So this comes from the TCEQ monitoring data. And the first thing I want to point out is that if you look at the colors, the background colors, you'll see that we generally have lower salinities on the upper coast, and it gets higher as we move to the south. And that follows that really well-defined precipitation gradient that we have, which I've put here as an inset toward the top. So we have that very sharp precipitation gradient, and that that really defines the characteristics of our estuaries on the Texas coast. The next thing you'll see is there are a few places where we're seeing obvious trends in terms of this data set. So up here in some of the tributaries of Galveston Bay, and then also in the Sabine Lake region, we've generally seen evidence of a freshening of those estuaries since the start of that data set. And that is fairly consistent with the earlier map I showed you of changing precipitation patterns on the Texas coast. So some evidence of freshening up on that part of the coast. For the rest of the Texas coast, it's really variable where we actually have any significant trends. So a few places we're seeing increasing salinity trends, a few other places decreases. So it's highly variable. A lot of places we're not actually seeing statistically significant trends with this data set. I just wanted to point out though that, you know, for this data, again, it goes back to the 90s, in some cases to the 1970s. So it's not painting the full picture of the changes that we've seen over the last century on the Texas coast, especially associated with that damming that happened in the mid 20th century. And again, the classic example of that I like to refer to is the Nueces estuary here in our backyard. So this system in the early 1900s, it was brackish and it supported just this amazing oyster fishery. So there, I've included a few historic pictures of just mounds of oyster shells from oysters that were harvested in this system. And of course, with that, we had issues like overharvesting that caused some problems. But then those were compounded by the construction of the dams and the changing hydrology of this system. So in the 50s through the 80s, that's when we had the reservoirs constructed on the Nueces River. And now we don't have brackish conditions in there anymore. It's basically a trickle of water that makes it down to the estuary. We don't really have a salinity gradient. And in fact, we commonly see hypersalinity in the upper parts of the estuary now, especially during drought conditions. The evaporation rate is just so high. It's not balanced by the fresh water coming in, so it gets hypersaline up in the upper part of the estuary. And the lower part of the estuary is now essentially at seawater salinity levels. So you can't grow oysters in Nueces Bay anymore. The salinities are just too high. So that's one example of how the altered freshwater inflows have had a real ecological impact on the estuary. And we're starting to see these concerns for our central coast estuaries a little bit north of here as well. So up around San Antonio Bay and up around Matagorda Bay. Both of those systems are downstream of our major metroplexes, so either San Antonio or the Austin area. And so consequently, what they're starting to see, especially during drought conditions, is their rivers are essentially drying up. And they're starting to also see indications of hypersalinity at times in those systems. It's not nearly as pronounced as it is down here, but it is starting to have an impact on, for example, oyster growth up there as well. So this is a major challenge that we're seeing here in Texas. How do we balance the human freshwater needs with those of the environment? Another interesting example of impacts of changing salinity that we've seen is with our red tide, Karenia brevis, which you all are very familiar with over there, unfortunately. So this is our toxin producing harmful algal bloom forming species. I had a student who did some really interesting data mining. And what she found is that here in the Nueces estuary in particular, there seems to have been an increase in the frequency of our red tide blooms on an annual basis. So this figure in the bottom right just shows the presence or absence of Karenia in a given year. And so the bars indicate presence. And so what she actually found was that there was a strong statistical relationship with salinity. So somewhere in the mid 1990s, that frequency of occurrence really started to ramp up. And again, strong relationship with salinity in the estuary. Karenia seems to like salinities in the range of about 25 to 35. So basically close to seawater levels. And so over time, as the Nueces estuary has become more salty, it seems to have become more favorable for these Karenia blooms. It was interesting too, she did not find any obvious relationships with salinity. I frequently hear people say that the Corpus Christi Bay is nasty and it's eutrophic, and in fact, it's not. Nutrient levels in the system are fairly low. So in this particular case, it appears that the Karenia brevis is able to find nutrients from must be a lot of different sources in the bay, but we don't have any obvious eutrophication issues, unlike over in Florida with some of the things you all are dealing with there. So in this case in particular, it seems to be that the salinity has changed to make the bay more habitable for Karenia. So looking forward in time, what are we dealing with? More people, less fresh water. So the top figure shows projected population growth in Texas. And you can see basically by 2070, we're expecting to have a doubling of our population. So what this means is, again, less water. The bottom right panel shows projected changes in the demand for water without climate change. And this came from the National Climate Assessment from about 7 or 8 years ago. And you can see just increases, pretty significant increases in freshwater demand without climate change. And once you factor in the impacts of warming and increasing evaporation rates, that means there's potentially even more demand for fresh water, especially for irrigation throughout much of Texas. And again, it's putting pressures on our estuarine ecosystem, so we're likely to see even further decreases in freshwater inflows and increasing salinities in the estuaries. So shifting gears a little bit out, so that's our broad overview of the salinity and inflow challenges we're facing. I want to shift gears and talk a little bit about fecal bacteria issues that we're now experiencing. So over the past few decades, we've had a few localized areas that we consider hotspots for fecal bacteria contamination. For instance, here in the Corpus Christi Bay area, we've had a long time issue with our storm drains that carry pet waste and that also unfortunately tie into some of our sewage treatment lines. So when it rains here in Corpus, you basically don't want to go in the water for about 48 hours because there are some significant issues with fecal bacteria in the water. So again, these localized issues are typically linked to wildlife or stormwater runoff and failing sewage treatment infrastructure. And the health implications are pretty obvious. Fecal bacteria can cause gastrointestinal issues, but also there's this perception issue that our beaches aren't clean. We've had some very noticeable problems recently, more widespread fecal bacteria issues here, especially on the central Texas coast, up around Matagorda, all the way up through up to the Galveston area. So for instance, in 2019, we had a very widespread fecal contamination event. So you can see the map here on the right showing where the very high levels were found. And not only was this a spatially expansive event, it lasted a while. So on the bottom right, it shows the timing of, it shows the enterococci levels. Anything above about 100 MPNs would be a significant problem. So it exceeds the EPA's beach action value. And so in about early to mid-June, we started seeing some spikes in the bacteria levels. and some variability through July, but in general, it was very high even during that time frame. And in particular, from mid-July through the end of August, we had very high levels consistently being measured at these beaches. So this event lasted basically close to 3 months and created some real problems. Again, from a perception standpoint, there's also a lot of anecdotal information coming in from surfers and beachgoers of illnesses, but it wasn't really until after the fact that we had a good idea of what was going on there. So a colleague of mine from the state's the state agency that deals with the bacterial problem reached out to a group of us here at A&M, and we put together a little team. So Nicole Powers, as a postdoc in another lab here, really did a lot of work to try and figure out what was going on with this event. And so she actually dived some more, not only into just this event, but also the historic bacteria data from the Texas coast. And so what she found in terms of potential drivers, a couple of different factors. She found decent correlations with population in a given watershed, especially for the Galveston area, and then from the central down to from the central Texas coast, pardon me. But she also found a relationship with sea level. And this was particularly interesting when we were trying to figure out, okay, what does sea level have to do with this? So looking at the rates of sea level rise on the Texas coast, this is an example from Galveston. 2019 in particular seemed to be a high water year. So there's been a consistent upward trend over time, but 2019 in particular was one of those high water years. And in general, the rates of sea level rise are relatively high for much of the central and north Texas coast. And this is primarily due to subsidence. So we've been extracting water, groundwater from the area and for other uses. And so we're seeing a lot of subsidence up in that upper part, central and upper part of the Texas coast. So what we think might be happening, and again, there's a lot of room for diving deeper into this issue, but what we think might be happening is that in those areas where we're seeing these high bacteria levels, there's a lot of septic tanks. And so it's quite possible that you've got the failing septic tanks combining with the water table that's slowly rising and then interacting with the drain fields that potentially is leading to these higher pollutant bacterial loads to the surface water and the groundwater. So kind of makes sense, since 2019 in particular was a high water year. We were kind of surprised when we started looking into this phenomenon and realized that this is also a problem over in Florida. And in fact, there in southeastern Florida in particular, there's been a lot of work done around the Fort Lauderdale area and some of those other urbanized areas where they're also seeing a similar phenomenon of sea level rise interacting with the septic tanks and creating these pollutant issues. So this was, I think, a decent first crack data analysis to try and identify what the problems might be. Where we are now, the state has funded 3 new research studies to better understand the processes that might be involved with the enhanced bacterial loadings. So looking at groundwater, surface water exchange of water, between the septic tanks and the beach, doing some more sophisticated source tracking studies. So the state's really serious about trying to figure out this problem, because the perception issue has been killing them from a tourism standpoint. So salinity, we talked about bacteria. I now want to shift gears and talk about nutrients, which is something that's on your minds, obviously, over there in Florida. It's something that's becoming more of an issue here. But surprisingly, from a nutrient standpoint, despite all the population growth that we've had, if I had to give a take-home message, I would say that our estuaries are in reasonably good shape, but we do have some hot spots. So this graph shows chlorophyll levels from that TCEQ monitoring program. And so the background colors just show that 10-year average. And you can see a few places in particular that stand out, the oranges. So up here in Galveston Bay, which is not shocking considering how urbanized that estuary is. But also down here in Baffin Bay, which David is a little bit familiar with. Baffin Bay doesn't have a lot of people living in its watershed, and yet we still see really high chlorophyll levels down there. Another place it's a little hard to see is called Oso Bay here around. It's basically surrounded by Corpus Christi, and it's heavily wastewater influenced, so not surprising that we have issues there as well. And where we've seen actual increasing trends, the obvious places up here in Galveston Bay, very, very widespread increases over time. Then also down here in Baffin Bay and the adjacent Laguna Madre ecosystem. We've seen trends, increasing trends going back to the 1970s down here. A few other places where we have issues up in Lavaca Bay and the western part of Matagorda Bay, here around Port Bay, which is starting to be heavily influenced by a couple of our more beachy type communities. Rockport in particular has been growing like crazy. So Port Bay gets a lot of stormwater runoff. And then of course down here in Oso Bay as well. So we've got a few obvious hotspots I'd call Galveston and Baffin Bay, and then a few other isolated areas. Now, the other interesting one is Nueces estuary. We've seen a long-term decrease in chlorophyll there. So what I suspect may be happening is with the decreasing freshwater inflow, not bringing nearly as much nutrients to the estuary as historically it did. I think it's essentially starving that Nueces estuary system. And again, we do see that with the decreasing chlorophyll levels there. So another indicator that we've looked at that's commonly measured for nutrients is the dissolved oxygen levels. And so a couple of things that stand out here. One is that if you look at the background colors, you generally see higher dissolved oxygen conditions on average. On the upper part of the coast, that is where we have the fresher water, which in general is going to hold more oxygen. And then as you get down into the saltier waters of the Laguna Madre, the dissolved oxygen levels are generally quite a bit lower. So the other thing that we've seen are some consistent decreases over time in dissolved oxygen. And again, that Baffin Bay Laguna Madre complex stands out as a place where we're seeing a long-term decrease in dissolved oxygen. Few other places, again, it's kind of hit and miss for the rest of the Texas coast. Parts of Galveston have seen increasing dissolved oxygen. Other parts have seen decreases. Again, very inconsistent for the rest of the coast. I want to point out, though, up here in the Nueces estuary, again, where that freshwater inflow has decreased and the chlorophyll has decreased, we're seeing an increasing oxygen trend there. But what I want to do now is spend a little bit more time on this sort of perplexing system, this Baffin Bay Upper Laguna Madre complex, because that's where I've done a lot of my process-based field work. And it's just a really interesting and unique system. And these dissolved oxygen and chlorophyll trends have traditionally been kind of a head scratcher for us, because again, this is a system that's not very heavily urbanized. So just to give you some background on Baffin Bay, here in Texas, we call it the jewel of the Texas coast. And it's just this really unique, special ecosystem. So it has these crazy, what we call the rocks of Baffin Bay. They're these ancient serpulid worm reefs that formed these rocks over thousands of years on the bottom. And they're only found in one other place in the world, and that's off of Scotland. So these rocks, I've got some pictures here, or these videos, just show the types of life that live on these rocks. they're essentially like our coral reefs of Baffin Bay, I guess you could say. There's an incredible diversity of fish species and invertebrates that live in all the little nooks and crannies of these rocks. The other thing that's really special about Texas is that it's about Baffin Bay is that it's isolated. Very probably about 45 miles in either direction before you get to any real significant population centers. And aside from that, what it's really known for, though, is the fishing. Really world-renowned fishing here in Baffin Bay for black drum, trout, red drum. And in fact, the populations of black drum and trout in particular are among the highest of any Texas estuary. So it's iconic from the sense of being isolated, for having these serpulid worm reefs, but then also just because of the fishing opportunities. And consequently, it's really a big contributor to our local economy. So when I first, my first real involvement with Baffin Bay started about 11 years ago. We started hearing from concerned community members about things they were seeing in the bay that might indicate that it's not healthy as it used to be. So I went down and visited with a group of about 40 or 50 people, and we learned a lot of stuff about the bay. But just the follow-up to that is we really started to delve into what data existed and what are some of the issues down there. So Baffin Bay has been home to the brown tide algal blooms. This is a species called Oriumbra lagunensis. It used to be referred to as the Texas brown tide, but since it first appeared here in 1989, it's now popped up in places like Indian River Lagoon over in your neck of the woods, also down in Guantanamo Bay in Florida. The first bloom that we had, again, started in 1989, and it lasted almost 8 years. So it's one of the longest running algal blooms in history. And basically when it happens, it turns the water like looks like chocolate milk. So it's really creates problems for seagrasses in particular because it shades them out and they die. And we've experienced very significant seagrass loss in Baffin Bay and the adjacent Upper Laguna Madre. Since the first bloom in '89, we've had several additional blooms since then. So this upper middle panel shows chlorophyll, and the brown areas indicate when brown tide dominated. So again, you can see this is kind of a recurring thing that we've had. Historically, it was unprecedented. Longtime anglers have commented they've never seen a bloom like this prior to '89. We've also had a lot of issues in Baffin with fish kills, recurring, and some pretty significant ones, including of trophy fish species that have coincided with low oxygen conditions and or algal blooms. So a lot of different indicators coming together to indicate that the bay is not as healthy as it used to be. So when we first started, though, there wasn't a lot of data from the system. We had some indications that there were water quality issues, but we didn't have a lot of great data other than the TCQ monitoring program. So what we did is recruited a group of about 18 citizen scientists to help us get more spatially explicit data from this system and more frequent data. So we were fortunate. We got a little bit of funding here and there, and we were able to start this volunteer water quality monitoring program where they essentially took us out every month on the bay to get data. So I just wanted to show a brief video of some of our volunteers in action.
Just completed the first year and it has some very interesting findings. And we're starting to really understand how Baffin Bay works from an environmental standpoint, when this interesting partnerships with the fisheries. And all of this, though, was really could have been done without the help of the volunteers as well as our partners. So all of this is really appreciated. I think it's going to much better understand what's going on with Baffin Bay.
So we're now in our 10th year of sampling in Baffin Bay, and we've got some really great data that's come together. But just to really pull it all together in a few slides without going into too much detail, what our data has shown is that Baffin Bay is really a hotspot for nutrients on the Texas coast. So this map, the background colors show data, average total Kaldol nitrogen levels from the TCEQ database. And you can see a few of those hotspots, but in particular, Baffin Bay and the Upper Laguna Madre. And then this data, this shows the dissolved organic nitrogen levels. So one of the interesting things about Baffin Bay is that if you go out at any given time and measure the dissolved nutrient pools, in particular nitrogen, it's almost all organic nitrogen. There is very little inorganic nitrogen in this system. And so what we've found, just looking at this and other systems, is the dissolved organic nitrogen levels in Baffin are at least twofold higher than just about anywhere else on the Texas coast as well. So it's this kind of hotspot for organic nitrogen enrichment. And since our work, well, I'd say accompanying our work, we've been working with colleagues who've been doing some very sophisticated source tracking of the nitrogen using isotopes. And what they've found is that there's actually a pretty significant signature of sewage in the bay, which we think is probably coming from the septic tanks around the bay. And then also what we've come to realize over the past 4 or 5 years or so is that we've got quite a number of smaller municipal wastewater plants that basically are not treating their water, or they're doing very minimal treatments. So we've seen instances of raw sewage being discharged into this bay. And so, so we definitely have some nutrient issues in the system. And so what we think's happening, just to kind of, again, pull everything together pretty quickly, is during our wet years, and I say during our wet years and dry years because this is a really flashy system. Some years we have these really long droughts, and then especially when we have El Nino, we do get a lot of rainfall. So during the wet years, we get this episodic high rainfall that brings in nutrients from the watershed. So we have a lot of row crop agriculture, but we also have a lot of rangeland. So that brings in organic nutrients and then some nitrate. And we also have the sewage coming in. What we found during the wet years is we tend to get some pretty big diatom blooms in the system. And even though the salinities are a little bit more moderated and the residence times are on the order of weeks to months in the system, I suspect that most of that diatom biomass still gets retained in the system, gets deposited in the sediments. And during the dry years, so that runoff from the ag lands, it's basically shut down. There's very little flow coming into the system from the creeks that run through the ag lands. But we still have the sewage coming in. And a colleague of mine has found that the DON actually is fairly reactive to sunlight. So the sunlight breaks down the organic nitrogen into ammonium that's then available for the brown tide. So it's during these dry years when we get these brown tide blooms that we think is feeding off the ammonia from the DON, maybe also some component of the DON itself. And then also we do have a significant efflux of ammonia coming out of the sediments. And during those dry years, we get resident time on the order of months to years. So it's a very poorly flushed system in general. So again, nutrients come into the system during the wet years, but also from the sewage, and then it just gets recycled and continues to form these blooms. So with all this data in hand and realizing that we have nutrient problems, we've formed a stakeholder group that is fairly vibrant and active. We started off with about 10 people in a room 5 years ago, and we're up to about 250 people representing a big cross section of the community. And basically the stakeholder group is trying to figure out how do we deal with the nutrients that are coming into this system. And we've had a few successes. As of late, we've received some funding through the Deepwater Horizon settlement through Restore. We also have developed what we call the Bringing Baffin Back initiative, which basically represents a sustained commitment to improve the health of the bay and the economy. So this is kind of our overarching approach for dealing with the conservation issues in the bay. And we were selected last year. You are probably not familiar with the Conservation Wrangler program, but this is a foundation that was started by former First Lady Laura Bush. And what they've done over the past 18 months, now that we've been selected as a partner with them, is they've really helped us to develop an outreach and marketing strategy, and are helping to basically amplify our reach in the watershed. So our approach is very, very simple. We want to get good data, continue to get good and more data that's then informing the watershed restoration and management. So the nutrient reduction phase of this. So we have now an EPA approved watershed protection plan in place for Baffin Bay. And we're also starting to get funding for projects that are helping to reduce the nutrient loads. And then once we start to get a handle on the nutrient levels and the water quality in the bay, then that's when we start to really think about restoring seagrass habitat and other habitat that's been lost in the bay. Overarching all of this, though, is that need to educate the community and making sure we have that next generation of stewards in place. And so we're doing a lot of work now trying to get kids on the bay, get them fishing, trying to work with school groups to better educate the kids in the community about, you know, connections between the land and the water. So a really exciting initiative overall. And we're just really at the starting point here in many regards. So I'm hopefully you'll hear more about us over the next few years. Okay, so I'm running out of time. Take home messages from all of this is that we do have localized examples of water quality degradation here in Texas. As a whole, I think we're doing reasonably well, but again, we're starting to see more and more issues. And we need to continue to monitor, improve our monitoring. Places where we do have issues, we need to engage with stakeholders. You know, we need to make sure that the state and the developers and local communities are addressing aging infrastructure, which is a big problem here in Texas, and also to make sure that they're utilizing better approaches for streets and sidewalks, so nature-based infrastructure, for example. That being said, moving forward, we're going to continue to see these stressors that I've talked about growing and becoming more problematic. So just a few examples. Obviously, air and water temperature is going to create pressures on nutrient cycling. Obviously, so increasing nutrient recycling, probably expanding that seasonal window for the growth of harmful microbes like Vibrio bacteria or some of our harmful algal bloom species. Warmer water temperature means less DO in our water bodies and potentially higher salinities due to evaporation. So of course we have the population increase, which is in the absence of mitigating factors going to lead to increased pollutant loads and potentially decreases in freshwater inflows and higher salinities as well. And then on top of that, we have this indication that we're seeing more extreme rainfall events, which can have acute impacts on pollutant loadings, oxygen conditions, HABs, et cetera, et cetera. So we're holding the line, I guess you could say, here in Texas. We don't have the major obvious issues that you all do there in Florida, but we are under pressure, and we need to really get on top of some of these issues. So with that being said, I think I've used up all my time, and I'm happy to answer any questions that you all may have.
All right, thanks, Mike. Let's give a round of applause to Dr. Wetz, either with your icon or real claps. Thanks so much. So we'll go in the room here, it's just the two of us, but then online on Zoom. So if you have any questions on Zoom, either pop them in the chat or you're welcome to. Okay, go ahead, Jason. You can unmute and ask your question.
Hey, thanks for coming and doing this talk. I think we really don't do enough interstate communicating about water quality problems that face us both here in Florida and in Texas. So I'm not happy to hear about problems you have with red tide, but it's a good reminder that there are a lot of people and scientists working on the same things all over the Gulf that we are here today, or we are in Florida also. But my question was about the source of the nitrogen and potentially the low DO levels and high algae levels in Baffin Bay. And is none of that linked to nearby agricultural operations on the north side of the bay? And if not, it seems like they're doing a really good job of containing that runoff with those operations, if that's not really implicated. Thanks.
Great question. So when I first started, people were screaming about the landowners on the north side of the bay. It's one of our big ranches around here. And so, I went into this thinking, that there may be some issues there just because of the fingerprint on the watershed. And what we've come to realize is that it's not as big as I originally thought it was. The nitrogen source tracking work, I feel very good about what my colleague David Felix has done with that work. And it is showing a pretty significant signature of sewage in this system. So the data from the source tracking is showing it, but also just observations. So for example, we commissioned a study of riparian habitat condition all along our creeks that flow into the bay. And those ranches up there actually have really healthy riparian zones. And what we found is that once you go further upstream to some of the smaller single family farms, that's where you run into issues with people mowing down the riparian zones right up to the creek, people basically having fertilizer blown into the creeks. So it seems like the ranches in general do a good job from a land management standpoint. The other thing we've seen, getting back to the sewage issue, is we've had verified reports of several of our wastewater plants dumping raw sewage into the creeks going down to the bay. So one of our partners with the Nueces River Authority is now, they've developed a nice outreach campaign to the municipal wastewater plants to try and help them get back up to code and to do a better job. We're also looking at developing some regional wastewater plants to take it out of the hands of some of these smaller communities. So to answer your question, I was surprised. I thought there would be a bigger signature from the ranches, but it seems like our low-hanging fruit is going to be the sewage issues.
Thank you.
Okay. All right, we have a question from, and of course, if you have to go to class, students, that's fine. We have a question from YouTube from Shaler. Do you think if the guidelines for septic tanks similar to landfills, let me get this right. I guess basically, do you think they're like improved guidelines for septic tank, either installation, maintenance, or even just technologies that'll help reduce the bacterial and nutrient loading?
Yeah, I mean, here in Texas, our soils are not great for septic tanks, so there are definitely some siting issues. That being said, I think the cost of bringing many of these onto county sewer is going to be prohibitive. So what we're actually doing around Baffin is we have a partner who has secured funding to actually go in and inspect and replace residences' septic tanks at no cost to the residences. So we're really trying to get more money into that program as a means of at least band-aiding this problem. But yeah, we have some issues with septic tank placement in particular that the state as a whole really needs to get serious about.
All right, thanks. Mark, do you have a question?
Yeah, I do. Thanks, Mike. That was a great talk. I really like the whole coastline sort of approach of where to assess and understand the context of a particular estuary relative to others, and the Baffin Bay focus. I'm kind of curious. It sounds like you've got a really nice working group, stakeholders interacting, engaging, trying to come up with a strategy going forward. It sounds like you've got a plan at the watershed scale. And I'm kind of curious how much of that was like stakeholder driven organic from kind of the bottom up based on the data you had, and how much of it was more from a regulatory kind of top down, state water quality standards, i.e. even EPA water quality standards that were forcing that issue? Because in Florida, TMDLs, nutrient criteria, you probably dealt with all that, and there's a pretty robust mechanism that is definitely top down, and then you get buy-in or not from the stakeholders. I'm just kind of curious in your situation, how did all this come about? Because it sounds like you got a pretty neat opportunity in buy-in.
Well, not to be facetious, but it's Texas, so we don't do regulation.
Yeah,
I mean, literally, the state had data. If they were serious about it 10 years ago, if they had looked at their data, that it was screaming at them that you have problems here. But we don't have nutrient criteria in the state, so that's a problem. So this has all been organic. This has been anglers who just love this system. If you get a chance, we have a nice little video on YouTube about bringing Baffin back, and you kind of hear the stories of these anglers who've been down there for 60 years or more. And so this really all started with the community kind of screaming about this. And since then, we've kind of pulled the regulators along, but they're still not really, I would say, doing their job, so to speak. So this is mostly a volunteer-based effort. Anyway, so does that answer your question?
Yeah, no, absolutely. And I kind of assumed that was going to be your answer. And now what I'm going to be curious is to see how effective that approach, meaning perhaps not the heavy-handed regulatory side, but really this bottom-up, user-driven process works relative to, what we've got is that heavy hand on the top-down side. And I guess where the challenges start to come in, and I had a similar question to Jason's, is where does ag fall within the contribution side? You've already identified and focused quite a bit on the urban sector, because outside of those actual people that are on the water and benefiting directly from those benefits, the drivers of this may be far afield, and so how do you kind of reach out and get them? But either way, I'll be interested to see how this progresses, because that model, your model, maybe better in the long run. We'll see.
Yeah, so I appreciate you asking that. And so we have a really strong connection with our local soil and water conservation district and with the state soil and water conservation board. In fact, our program manager up there, he has a farm down on Baffin, so he has a lot of connections in that area. So this year we're actually starting a big outreach campaign to the farmers in the area. I don't know what the success rate will be, but we do plan to really engage with them and see where we can go.
Yeah, well, best of luck, because I think that if you can get the all the stakeholders involved in understanding the issue, then I think you have probably a much better chance of addressing things than always a top down, or at least I think it's easier to get the buy-in process. Yeah. Great. Well, thanks again.
Thank you.
All right, thanks, Mike. We'll give one more round of applause. Thank you for zooming in with us today. And for next week, folks, we will be in person here in the seminar room, and we will have, let's just see 1 second. Oh, no, we're going to be virtual again next week. So for all of Dr. Clark's students, we will be virtual. We have Catherine Annard from NC State University. So about cascading feedbacks arising from coastal management. Until then, be good, be safe, take care of each other, and talk to you soon. Thanks again.
Y'all later.
Cheers.